Okay, so moving into a new unit today, the first thing we want to look at is rearranging formulas to solve a problem. So we want to use the same steps that you would use to solve any equation, and that's by moving everything away from the variable that you want. And in order to do this, whatever you do to one side of the equation, you must do to the other side, or to get rid of something on one side, you have to do the opposite of that to the other side. And when we rearrange the formula, we want to do the reverse of BEDMAS, which is SAMDEB. Okay, so we're using that when we move across the equal sign. Okay, so we need to rearrange the formulas for the indicated variables. So what these have is a lot of different variables in the equations. We don't necessarily have numbers every time. So this first one is y equals mx plus b, and we want to rearrange it for m. So we want to get m by itself. The operations that we have here, we have multiplying between the m and the x, and we have adding the plus b on the end. Okay, so using SAMDEB, that means we want to move any adding or subtracting first. That means we're moving this plus b to the other side, and it'll become minus b. So y minus b equals mx. And then we have our m times x. We want to get m by itself. Because this is multiplying, to get it to the other side, we divide. So y minus b over m, we're solving for m, over x equals m. Okay, so that's our new equation when we have m by itself. Okay, the next one here is v equals pi r squared times h divided by 3. We want to solve for h. Okay, so using SAMDEB, we actually have all multiplication and division. So it does not matter what you move first, and you could technically move everything at the same time if you wanted to. But the first thing we're going to do is move this divide by 3 here. When you move it to the other side, it'll become multiply. So we'll have 3v equals pi r squared times h. Because we want to solve for h, we want to move this pi r squared to the other side. Since these are all multiplying, the opposite of multiplying, bringing it over, is dividing. So we're going to have 3v over pi r squared equal to our height. Okay, looking at a couple more examples. This next one we want to rearrange for f. So we have k equals 5f over 9 plus 255. Using SAMDEB, we move the adding and subtracting first. So moving that plus 255 to the other side becomes a minus. K minus 255 equals 5f over 9. Next thing we can move is this divided by 9. Bringing it over is multiplying. So both pieces, both terms on that left side get multiplied by 9. So that's 9 times k, and the minus 255 times 9 as well gives us 5f. and then getting f by itself, the 5 is multiplied here, bringing it over will be dividing. Okay. And if we wanted to simplify there, we could do the 255 times 9 as well. Next one, b equals m over h squared, and we want to solve for h. Okay, so looking at this here, we're going to have to do a couple of steps to get h by itself since it's on the bottom. So the divided by h squared here, instead of dividing, we're going to bring it over here, multiply. So h squared b equals m. We need to move the b away from the h squared. Since that's multiplying, bringing it across the equals will become divide. H squared equals m over b. And the last step is to move the squared. The opposite of squared is a square root. Okay, and of the SAMDEB, we moved the multiplying and dividing first before the exponent. So h equals the square root of m over b. Okay, so you make sure that the square root is clearly covering the whole piece, and we don't have just the square root on the top piece. Okay, the next equation here, c equals 5 times f minus 32 divided by 9. This is the temperature in Fahrenheit as it relates to the temperature in Celsius. If the temperature is 100 degrees Fahrenheit, what is the temperature in Celsius? So this one here, we're being asked what the temperature is in Celsius. We are given the temperature in Fahrenheit, so we just plug that into the equation. C equals 5 times bracket 100 minus 32, and that's divided by 9. Because nothing's being moved across the equal sign, we're using BEDMAS to just solve here. So the first thing we need to do is the brackets. So 100 minus 32 gives us 68. So 5 times 68 divided by 9. And we get 37.8 degrees Celsius. Okay, part B, rearrange the formula so that F is written by itself. Okay, so with our formula, C equals 5 bracket 5 F minus 32, and that's divided by 9. The first thing there, we want to move that divide by 9 to the other side. It's going to be multiply. So we'll have 9c equals 5 times f minus 32. Okay, again, using SAMDEB, there was no adding or subtracting on its own first, so we're ignoring that. Then multiplying and dividing, so we moved the divide by 9. We now can move the multiply by 5. When we bring it over, it'll be divide. And the last piece, there's no exponents, so the last piece is brackets. So we can drop the brackets here, and then we're going to move the subtract 32 to the other side, and it will be adding 32. So we'll have 9c over 5. Oops. plus 32 equals F. And C, determine the Fahrenheit if Celsius is 0. Okay, so we're going to use that new formula, and we're given Celsius being 0, so we replace C with 0. So 9 times 0 divided by 5 plus 32 is equal to our Fahrenheit. 9 times 0 is 0, 0 divided by 5, still 0, plus 32. So 32 degrees Fahrenheit is what we get. Okay, so when we are using formulas to solve problems, you are presenting a solution, not just an answer. So the strategy, what is given, what is the formula? So use the formula as a checklist to make sure you have all the information you will need. You can draw a picture if it helps. What is required of us to answer? What is the question? Are there multiple steps that we are going to have to take to solve the problem? We're going to have to use bed mass, and then check, did you answer the whole question? Write a statement that answers the question. Be careful with units. Does your answer make sense? Okay, so think about what you're being asked and the steps you can take. So drawing a diagram, listing all that you're given in the question, or underlining it as you read it. And if we put a therefore statement at the end, we know that we have gone back, read the exact question we're being asked, and making sure that we answered it. Okay, so this one here, pediatric nurses use Young's formula, C equals AG over G plus 12, to calculate a child's dose of medicine. C milligrams, when the adult dose A milligrams and the child's age G years are known. Suppose the adult dose of a certain medication is 600 milligrams. Determine the corresponding dose for a 3-year-old child. Okay, so our C is our child's dose. Our A is the adult dose. Okay, we're given an adult dose in the question. So A equals 600 milligrams. And G is the child's age in years, which we know is for a 3-year-old. And we need to calculate the child's dose, C. Okay, so because we're solving for C, we don't need to rearrange the equation. We're just going to plug in all that we know. So C equals AG over G plus 12. Our A is 600. Our G is 3. Okay, so here we need to multiply the numbers up top. So 600 times 3. This gives us 1800. And we solve the bottom. 3 plus 12, which is 15. So 1800 divided by 15, this gives us 120 milligrams. Okay, since we started in milligrams, that is the unit we are using. So therefore, the child dose is 120 milligrams. Okay, so thinking about that, we've answered the question because it's asking to find the child's dose. And thinking about the answer we got of 120 milligrams, it should be less than an adult takes of the medicine. and it's saying the adult dose is the 600. So because that is a smaller number, this answer makes sense. Okay. A landscaper uses a bucket with radius 18 centimeters and height 18 centimeters to pour soil into a rectangular planter that measures 1 meter by 40 centimeters by 20 centimeters. How many buckets of soil are needed to fill the planter? Okay, so we're already given diagrams here, so we don't need to draw those out. I do see one problem with our units. Everything is in centimeters except the length of our planter, which is 1 meter. So we want to convert that to centimeters. So how many centimeters are in a meter? So that means this is 100 centimeters. Okay. Now, what is the question asking us? We need to know how many buckets we're filling this bucket with soil and it's being dumped into the planter. So how many times do we need to fill this? And if we are filling an object, what are the units that we're using? What is the measure that we're trying to find? So in order to fill this up, we're going to find the volume of it. We also need to know the volume of the planter. So the volume of the planter, since it's a rectangular prism, is length times width times height. Okay, we know our measurements, 100, 40, and 20. 100 times 40 times 20. That gives us 80,000 centimeters cubed. And the volume of the bucket, which is a cylinder, and that means the formula is volume equals pi r squared times the height. Okay, it does give us the radius. You have to be careful with the cylinder, whether it's talking diameter or radius, but it does give us the radius here, so we can use that 18 and a height of 18. So that's 3.14 times 18 squared times 18. Order of operations, you need to do the exponents first, so 18 squared and multiplying by 3.14 and by 18, and we get 18,312.48 centimeters cubed. Okay, so we found the volume of both the planter and the bucket, but the question is asking us how many buckets we need to fill the planter. So how many times do we need to fill to get to this volume here? So what we can do is take the volume of the planter and we divide by the volume of the bucket to get our number of buckets. So that's 80,000 divided by the 18,312.48. And we get 4.4 as our answer. So if we wanted to round that up, 4 buckets wouldn't be enough, so then we can say that we would need 5 buckets to fill the planter. Okay. keep in mind the formula you're going to use, the variable that you need to solve for, and then if it's on the same side of the equation, you're going to use BEDMAS. If you're moving things to the opposite side, then you use SAMDET. Okay, so answering the following textbook questions, and if you have any questions, please ask.